Today, we're diving into the incredible world of machine perception. We're going to be looking at how we're teaching computers to see, hear, and even feel the world in ways that, well, until now have been uniquely human.
I want you to just think about that for a second. What if the very device you're watching this on right now could see, hear, and maybe even touch the world around it with the same kind of nuance that you do? It sounds like something straight out of science fiction, right? But it's not. It's the real ambition behind a field called machine perception.
So, what is it, really? Well, at its heart, machine perception is about giving a computer the ability to take in data from the world, images, sounds, textures, and interpret it in a way that mimics how our own senses work. Think of it as building a bridge between raw, cold data and a genuine, human-like understanding of reality. And the ultimate goal here, it's huge. It's not just about a machine collecting a bunch of data points. It's about creating a machine that can see, feel, and truly perceive its environment. That's what would lead to a much deeper, more intuitive relationship between us and our technology.
Okay, so where do we even start with something so massive? Let's begin with the sense we humans rely on most, our sight. We're going to look at how we're giving machines their very own set of digital eyes.
This is the world of computer vision, and it's a massive field, all dedicated to training machines to not just see, but to acquire, process, and actually understand visual information. And that word, understand, that's the key. It's about turning a bunch of pixels on a screen into real, actionable information and ultimately decisions.
And you have definitely come across this in your own life. I mean, think about your phone unlocking just by seeing your face. That's facial recognition, or the complex geographical modeling used in all our mapping apps. Heck, scientists are even training machines to make judgments on aesthetics, trying to figure out what exactly makes an image beautiful to us.
But this is also where we see a major gap. Our brains are just incredible at filling in the blanks. We can recognize a friend in a blurry, out-of-focus photo, or see a pile of objects as separate things. For a computer, that's incredibly confusing. This all ties back to Gestalt psychology, which studies how our brains just automatically group things together. Cracking that code is a massive hurdle for AI. All right, so let's move on to the next sense and see how this all connects. From sight, we're going to sound. How in the world are we teaching computers to listen?
This is called machine hearing, or sometimes people call it computer audition. It's all about a machine's ability to take in all kinds of sound data, whether that's a person talking, the complexities of an orchestra, or just the noise in the background, and process it in a meaningful way.
And just like computer vision, this tech is absolutely everywhere. It's the foundation of how music gets recorded and compressed. It's the tech behind those synthetic voices in our GPS. And of course, it's right there in our pockets. Every single time you talk to your smartphone or use a voice translator, you're using some seriously sophisticated machine hearing.
But here again, there's a huge difference between us and the machines. We are masters of what's called auditory scene analysis. That ability to stand in a loud, crowded party and just tune everything else out to focus on one single conversation. Machines really, really struggle with this, especially with something called speech segmentation, just figuring out where one word ends and the next one begins. And it gets even harder for them with unfamiliar accents. Vision and hearing are definitely the most developed areas, but the research goes way further. Scientists are also hard at work trying to replicate our other senses, starting with touch. Machine touch is all about processing tactile information, things like pressure and texture. The goal is to give robots the kind of dexterity they need to handle delicate objects. But it's important to remember this is all just data. It can't measure subjective experiences, like physical pain. Then you have machine olfaction, which is basically a sense of smell for a computer. This uses a device called an electronic nose. It's essentially a whole array of tiny sensors that can detect chemicals in the air, classify them, and even measure how concentrated they are. It's literally teaching a machine to recognize a smell. And of course, there's machine taste, which uses an electronic tongue. This device has chemical sensors that detect compounds dissolved in liquid, just like our taste buds do. And what's kind of wild is that sometimes these sensors can be even more sensitive than our own. And this isn't just some vague idea. The official scientific definition describes these tools as being able to recognize the exact quantitative and qualitative makeup of solutions. So, in other words, they're creating a unique chemical fingerprint for every single taste imaginable. So, we've got machines that can see, hear, touch, smell, and taste. Problem solved, right? The job's done? Well, not quite. Not even close. Because now we have to talk about the single biggest challenge in this entire field, the perception gap. Because it turns out that simply sensing the world is not the same thing as perceiving it. There are these deep, almost philosophical roadblocks that separate a machine's ability to just collect data from our very human ability to truly understand and experience it. The challenges are just immense, and they touch on major theories and paradoxes in cognitive science. We're talking about big ideas like embodied cognition, the theory that you need a physical body to truly think, or Moravec's paradox, which points out that things that are super easy for us, like walking, are incredibly hard for robots, while complex math is a piece of cake for them. These aren't just technical glitches, they're deeply philosophical problems. Let me give you a really concrete example of this: the recognition by components theory. When you see a mug of hot coffee, you don't just see mug. Your brain instantly, without you even trying, breaks it down into its parts: a cylinder for the liquid and a handle for holding. And your brain makes an unconscious inference: use the handle so you don't get burned. That simple, intuitive mental breakdown is an enormous challenge for a machine, and it's why a household robot might struggle with a task as simple as clearing the dimmer table. So this is the crucial point. The end goal isn't just to build a machine that acts correctly, it's to build a machine that can explain itself in a way we can understand. A machine that can tell us why it made a certain choice, and maybe even more importantly, tell us why it failed when it got something wrong. That requires a level of self-awareness that goes so far beyond just processing data.
And that really brings us to the core tension of this entire topic. Today, machines can absolutely sense the world, sometimes with incredible accuracy, better than we can. But can they truly perceive it? Can they build an internal, subjective experience of the world? That, right there, remains the ultimate question.
And I'll leave you with this one final thought to chew on. As these machines get better and better at perceiving our world in a human-like way, how is that going to change the way our world begins to perceive them?